Today we're going to show you how to prepare sodium azide. It's a chemical curiosity because the azide ion comprises 3 nitrogens with an overall 1- charge. They're generally not very stable compounds, although the alkali metal salts can be made and handled relatively safely. One tip to begin with. We performed this reaction a few times to see if potassium and sodium hydroxide worked, and also using both isopropanol and ethanol as solvents. We got the best yields when our glassware and reagents were carefully dried. Okay, our starting material for the reaction is hydrazine sulfate. We're using 30 grams of this. We dried this over calcium chloride for a few days. Check out our previous video for details of how you can make this using urea and sodium hypochlorite bleach. Here we've got 50 ml of absolute ethanol. Note that you can also use isopropanol for this reaction, and we tested it in a reaction run using potassium hydroxide and it worked fine. Let's add this to the hydrazine sulfate. The first step in our reaction is to convert our hydrazine salt into free hydrazine. This will dissolve in the alcohol and we can then decant or filter it off. Okay, here we go. We used plastic wrap to cover this just to avoid moisture getting in, and also to protect us from hydrazine fumes during the next step. Next, prepare a cooling bath with some ice and cold water. Our reaction to release hydrazine from the salt is going to give off a lot of heat and you do need to cool the mixture well. Okay, we're set up now. To release the hydrazine from hydrazine sulfate, we're going to use 1 mole equivalent of sodium hydroxide. So we've got 9.2 grams here. Note that you'll need 2 more portions of sodium hydroxide with this way later on in the reaction as well. And potassium hydroxide works fine as well. Add the sodium hydroxide to the hydrazine sulfate in the ethanol or IPA. And stir it in well. The reaction will require a lot of stirring to get it to complete properly, and you'll notice the temperature in the beaker goes up quite considerably. We added the hydroxide into portions. Stirred well and let the mixture cool. We kept stirring and cooling until we couldn't feel any more heat being generated, which took about 20 minutes. You can see there's a dense slurry in here, which is sodium hydrogen sulfate. You could filter now and try to extract the ethanol, but it's not very efficient and a lot of the hydrazine gets left behind. But there's a neat trick. Measure out another 9.2 gram portion of sodium hydroxide. And with the mixture sitting in the ice bath, add this to the mixture and then stir well again. Some more heat will be generated. We're now converting the sodium hydrogen sulfate into sodium sulfate. This is also going to generate some water, but that should be absorbed by the sodium sulfate forming a hydrate. You'll need to stir the mixture well for about 10 minutes to get the reaction to complete. The result should be a much finer white precipitate which settles to the bottom of the beaker. Now we can decant off the alcohol, which now contains our free hydrazine base. Prepare a dry storage bottle just to hold the mixture temporarily, and then decant off the alcohol hydrazine solution. Take care not to breathe in any fumes from this because hydrazine is highly toxic. Shake the residual slurry in the beaker to get more liquid out, and then decant this. Note you can also use a vacuum pump if you want to, but you're going to risk hydrazine fumes coming out of the air outlet, which we didn't want. Now wash the residual solid with another 20 ml of absolute ethanol or isopropanol. And then decant the liquid again. If you think you can get more out, go for it with another 10 or 20 ml of solvent. We stopped at 2 extractions though. Okay, here's our solution of hydrazine in our alcohol solvent. Now let's prepare the other reagents we need for the main reaction, and get everything set up ready. We're going to need an organic nitrite ester for the reaction in a 1.2 molar ratio to the hydrazine. We're using isopropyl nitrite, which we prepared in a previous video. Check it out for more information about how to make this. We've got ours drying over some anhydrous magnesium sulfate. And we're also going to need a third and final portion of sodium hydroxide. We've got 9.3 grams weighed out here, which is a very slight excess. Note that if you want to make potassium azide, then you can use potassium hydroxide here and it works just fine. Here's our 3 reagents ready. So let's take you on the tour of the reaction setup. Here we go. Pretty sexy looking. First of all, we've got a hot plate and we've got the 500 ml flask set up with a nice strong magnetic stir bar in. Above this we've got an addition funnel with a ground glass joint. Please don't try to perform this reaction in an open vessel. It's exothermic and you will be exposed to a lot of very toxic vapors. It would be extremely dangerous. And now also attached to the flask we've got a reflux condenser. This has cold water running through it, cooled by ice. Hydrazine and isopropyl nitrite are very volatile and so it's important to use cold water here. Okay, first thing we're going to do is add the alcoholic hydrazine solution we prepared. Here we go. And now we add the solid sodium hydroxide. Close the apparatus up and now stir vigorously to get the hydroxide to dissolve. This will take a few minutes. A bit of heat will also be generated, and you can also apply some heat via the hot plate if you need to in order to get it to dissolve. Using sodium hydroxide, you may also need to add a further 10 or 20 ml of alcohol solvent through the condenser. Potassium hydroxide is more soluble and seems to dissolve without this. Nearly there now. Now here's 28 ml of our dry isopropyl nitrite. This is approximately a 1.2 molar excess compared to the hydrazine. Double and triple check the tap is closed. And add the nitrite to the addition funnel. The hydroxide has dissolved, so we're now armed and dangerous and ready to rock. Start the addition slowly. White fumes will appear in the apparatus, and the mixture will start to get hot. Soon the cloudiness appears and we notice our stir bar starting to make strange noises as a solid starts to form in the mixture. Soon the mixture starts to reflux with the heat produced. Keep the addition going steadily and it should take about 30 minutes to complete. Watch your condenser. If you see white wisps of smoke, then get your ventilation going because you've got hydrazine escaping. The cold water and an efficient condenser worked well in our case. Okay, addition is complete. About 35 minutes later, Now we're going to turn the heat up and continue to reflux the mixture for an additional 20 minutes to complete the reaction. At the end of this time the white smoke has gone and the mixture is thick with solid product. Allow the reaction mixture to cool, then dismantle the apparatus, and then chill the mixture down to fridge temperature in order to ensure complete precipitation of the sodium azide. And now set up to filter. Wash with 25 ml of cold alcohol solvent. And dry thoroughly for about 20 minutes, breaking up the fluffy white powder. Here our product. Pure white fluffy dry powdered sodium azide. We collected 12.8 grams, which works out to be a spectacular 85% yield on the starting hydrazine sulfate. Don't let looks deceive you though. This fluffy white powder is a deadly poison and you should take as much care with this as you would with cyanide salts. The lethal dose is about half a gram, but doses as small as 20 milligrams can cause quite profound and unpleasant toxic effects. So please do take great care with azides. They are not called the evil cousins of cyanides for nothing. Well, no video on azides would be complete without a little test. Here's a very small amount in the end of a metal spatula. That's a pretty convincing result. Azides decompose violently on heating into nitrogen gas and metallic sodium metal. Heavy metal azides such as lead and mercury are high explosives and used as detonators. We won't be making those. One other thing to be careful of with azides: if they contact acids, then hydrozoic acid will be produced. This is an extremely poisonous and volatile compound, and even in tiny quantities will give you a migraine headache for hours on end. It's also an extremely dangerous explosive. Well, we're not totally sure what we're going to do with our sodium azide. It's a chemical curiosity for sure. Azides are also supernucleophiles and very useful in some organic reactions. But organic azides are very dangerous, and until we have a procedure that we're 100% happy with, we won't be trying these reactions out. The nucleophilic properties mean that they can react quite easily with chlorinated solvents to produce dangerously explosive substances. So another warning: don't mix azides and chlorinated solvents. We've recently upgraded the Kimplayer YouTube site, as we hope you like the new format. We have also created a Twitter account, so if you like you can also use that to follow our work. We'll tweet when we have new videos out, but also other stuff about what we're doing and some interesting information that's not in the videos. Look out for our next video, where we'll tell you all about our voluntary donation system we're setting up. If this is successful, then we'll not only be able to buy a beer or two to celebrate that someone loves us, but we'll also be able to focus on some research projects. We'll explain what they are too. We think you're going to like them. Thanks for watching and stay tuned.